Hello everyone, I'm Simos Kazantzidis and I have been working on developing a graphical interface which can visualize and cluster PELE's results. The exact title of my project is Collaborative Interface for In-situ Visualization and Steering of HPC Molecular Dynamic Simulation. The project is being carried out in HPC and more specifically in Barcelona Supercomputer Research Center. Let's see a brief introduction. Molecular docking is a well-known procedure that allows to calculate and predict molecule-to-molecule combination, such as the ligand-protein. The most common docking procedure involves the goal of the ligand-protein combination in the area of drug design. PELE simulation software gives us the opportunity to model such an interaction by inserting program database files known as PDB files with the protein structure of interest. The PELE program starts analyzing and computing the best fitting site and present an atomic view of these interactions. My work here consists of developing a graphical interface which can visualize and cluster PELE's results in order to evaluate the best matching solution. A combination of D3GS library, WebSocket technology and JSMall visualization techniques has been used in order to obtain our project goals. D3GS is a JavaScript library that helps us create and build the required data visualization framework. WebSocket technology allows the creation of TCP socket connection between the client user and the server Tornado. The visualization of result is being rendered through the 2D figure, and if the user has chosen a circle, he will be able to see the protein structure through the JSMall. In the diagram, we can see how the connection between PELE, Tornado server, Prosody, and our GUI is being established. A user submits his protein and ligand in the PELE software. PELE will then create spatial position, moving and rotating the two proteins, and get a metric result. At this point, our visualization procedure is being started. At the beginning, the proteins are being presented as black painting dots. In our implementation, after the user presses the button of the parameters windows, the cluster of Prosody is given the result, and our GUI represents the cluster with different color on a Voronoi diagram. The color differentiation of the cluster result is based on the algorithm using the HSL geometric cylinder. Using its hue, lightness, and saturation characteristics and setting upper and lower bounds allows us to get color shades that can be distinguished by the human eye. Lighter shades are being used for Voronoi background. A zoom-in semantic is being implemented for the zoom-in and zoom-out effect, so that the dots can be successfully adapted and distinguished. Also note that the web page is being adjusting to the screen size each time as well. The following is showing the general optical view of our graphical interface. Let's see how a user can navigate through it. At first, the user is clicking the button in order to get the result. Otherwise, the diagram is represented with the black dots. After he has submitted the parameters, he now can plot the protein with the one clustering option. The user can change axis parameters, use the zoom in and zoom out. He also can plot another clustering, and by selecting a dot, a protein, he can watch the protein structure in the JMall. The rectangle option gives the user the opportunity to select more than one dot's proteins in order to get information only for these proteins and finally to compare them. The multiple cluster option allows the user to plot all the cluster results in the same window. By double-clicking each plot, the plotting image is appearing larger in order to see further details. Having selected one clustering with the multiple axis option, we can get all the possible axis combination in one figure. The shape of the dots can help the user to compare results. With a double click, he can also plot an image in a larger appearance. With the bar cluster option, clustering bars are being represented with the score of each clustering that has been given from Prosody. A drop-down menu is giving the opportunity to select different values, such as cluster size, noise, etc. Another useful tool is the JMall appearance. The user can select between 1, 2, or none. If he selects the appearance of two JMOL, two icons are being represented with its JMOL title, in order to be informed of which dot has been selected in each. Furthermore, each JMOL background gets the color of the representative dot. Finally, the user can select the general info option for the selected cluster in order to get information about it, such as the algorithm that has been used, how many clusters it consists of, etc. We have shown how to visualize, cluster, evaluate PELE's result by using a server, by-processing clustering method, and graphical interface. This visualization provides more than a graphical representation of the protein structure by pointing on the specific dot or by selecting the whole area of dots with a rectangle choice. General information is given every time a user is interested in, such as evaluation, number of clusters, etc. Even the plotting options are enriched with many functions. Our GUI for PELE is a user-friendly graphical interface which is easily managed even by users with a little experience in this field by using the tools and effects it provides, such as the mouse over information triggering effect. Future work will be able to show the graphical interface surroundings working on the basic version of PELE. Finally, the website is available in the URL you can see. Thank you very much.